Hi and Assalamualaikum warahmatullahi wabarakatuh. In this video, we will provide the information on how to produce vitamin C via fermentation process. We hope this video will be helpful to everyone.
So, what is vitamin C? Vitamin C, or also known as L-ascorbic acid, is a water-soluble vitamin that is naturally present in some foods, added to the others, and available as a dietary supplement. It is necessary for the growth, development, and repairing of the tissue cells. It also involved in many body functions such as formation of collagen, absorption of iron, and maintenance of cartilage, bone, and teeth. Humans are unable to synthesize vitamin C endogenously, so it is an essential dietary component. The health benefits of vitamin C. First, skin aging. Vitamin C can affect the cell inside and outside of the body, and it is an antioxidant properties that can be beneficial when it comes to aging. Based on study by American Journal of Clinical Nutrition, the higher the consumption of vitamin C for women aged 40 to 47, the lower the likelihood to get wrinkles, dryness on skin, and a better skin appearance. Second, it can help to reduce the risk to get chronic disease. It is a powerful antioxidant that can strengthen the body's natural defense. Antioxidants are molecules that can boost the immune system. Third, it can help to manage high blood pressure. It has been found to lower the blood pressure in both healthy adults and those with high blood pressure.
There are two methods to produce vitamin C via fermentation. The first method is the Reichstein method. Reichstein method is a combination of chemical and microbial methods. The second method is the two-step fermentation process. Currently, most labs are using this method to produce vitamin C. Now, let's see what is Reichstein method.
The health benefits
Reichstein process is combined chemical and microbial method for production of ascorbic acid, which is vitamin C. It devised by Nobel Prize winner Thaddeus Reichstein and his colleagues in 1933. Reichstein process for vitamin C synthesis starts from D-glucose. The first step is dehydrogenation of D-glucose to D-sorbitol and organoreaction with nickel as a catalyst under high temperature and high pressure. This sorbitol production by glucose solution is injected into the column of reactor that containing solid catalyst by high pressure pump. The second step is the microbial oxidation or fermentation of sorbitol to L-sorbose with gluconobacter species at pH 4 until 6 and 30 degrees Celsius. The protections of the 4-hydroxy groups in sorbose by formations of the acetyl with acetone and an acid to diacetone L-sorbose. The fourth step is the organic oxidations with potassium permanganate followed by heating with water give the 2-keto L-gulonic acids. And the final steps is a ring closing step or gamma lactonization with removal of water. All these steps involve in upstream and downstream process to produce vitamin C. The advantages of using Reichstein process for vitamin C synthesis, it improves the fermentation efficiency for the industrial productions of vitamin C, and it reduces the capital investment that this technology offers, provide a better potential for new ascorbic acid production investment. The advantages of using this process, it is highly energy consuming and it relies on the use of a number of environmentally hazardous chemicals.
Now, we will see what is two-step fermentation process. Before we continue, we need to identify which bacterial strain is suitable for the fermentation process. the bacterial strains need to be chosen carefully for the fermentation to be a success. In the first fermentation step, the bacterial strains must have the ability to convert D-sorbitol to L-sorbose. This strain needs to contain membrane-bound dehydrogenases to facilitate oxidation reactions from D-sorbitol to L-sorbose. For example, Gluconobacter suboxidans. In the second step fermentation, there are two types of strains needed, which are the companion strain and the conversion strain. The companion strain is needed to stimulate bacterial growth and increase the 2-KLG yield. Mostly, spore-forming strains can be used as companion strain, for example, Bacillus cereus. Another strain is the conversion strain, which needs to contain enzymes L-sorbose dehydrogenase (SSDH) and L-sorbosone dehydrogenase (SNDH) to convert L-sorbose to 2-KLG by oxidation. For example, K. vulgare. Why two-step fermentation process is more favored? Firstly, they are cost efficient. When producing vitamin C, we need less equipment needed, hence less money used. Secondly, they make high-quality vitamin C. This is because we only focus on one batch of vitamin C at once. Thirdly, they are environmentally friendly and safe. This is because less harmful chemicals are being used during production. Now, we will explain in detail how vitamin C is produced nowadays using the two-step fermentation process.
Two-step fermentation process of vitamin C. The two-step fermentation process in a way can be considered as improved version of Rankine process in fermentation of ascorbic acid. As the name suggests, there are two fermentation steps in this fermentation process. First of all, D-glucose will undergo catalytic hydrogenation and form D-sorbitol. After that, from this point, the first step of fermentation will start, which D-sorbitol will be oxidized to L-sorbose by G-oxidants. Then it will continue to second step of this fermentation process, which L-sorbose will be converted to 2-keto-L-gluconic acid. Basically, there are two kinds of strain, a companion strain and conversion strain that involved in this step. And for the last step, basically the 2-KLG is converted to L-ascorbic acid by chemical method, which involve lactonization and esterification. This last step started as the 2-KLG and methanol will be transformed to methyl 2-keto-L-gluconate in the presence of the concentrated sulfuric acid as a catalyst. Then, the 2-methyl 2-keto-L-gluconate is then converted to ascorbic acid sodium salt by lactonization reaction with NaHCO3. And finally, the ascorbic acid sodium salt will undergo esterification reaction with H2SO4 to form L-ascorbic acid, or we known as the vitamin C.